Good morning to one and all. Today we are going to discuss about the binary, binary tree traverses methods. Here, first of all, we have to know about the what is the binary tree. Then, what is the traverses and what is the use of traverses and how the traversing is going on in the binary tree. Today, we are going to discuss about all these topics. First, first of all, what is the binary tree? Here, binary tree is the special type of generic tree in which each node can have at most two children. So, what is the meaning of this means? Here, the binary tree is having the at most two children. That means doesn't have any children, or it may have contained the one or at most two children. So, binary tree is generally partitioned into three disjoint subjects. So, what that disjoint subset means the root of the node, left subtree which is also is binary tree and right binary subtree. Let us move the next slide. Here in this peak it is represent the binary tree. Just we observe that here T1 root node, T3 is the three disjoint subsets of the tree. Here A is the root node, T1 is the left subtree of root node A, T2 is the right subtree of root node A. Here again T1 is the binary tree. Here T2 is the binary tree. Here in T1 B the root node, D is the left child of B, E is the right child of B. In T2 C is the root node, F is the left node of C, G is the right node of C. Here then up to this we have discussed about the what is the binary tree and how it is. Now we have to discuss about the traverses of binary tree. First of all, what is the traversing? Traversing means the process of visiting each node in a tree is nothing but traverses. Here, why you have to traverse? Traversing is why you have to necessity means checking whether the insertions or deletions work properly or not. Second one is the searching a specific node. Because of these, you have to need the traversal in either in binary tree or graph. So, what is the applications of traversal? Means here make a clone or determine the height. How much of height of this binary tree is determined because of traversals only. Here determine number of nodes. After visiting of each node only, you have to determine how many nodes are present in binary tree. So, here coming to our main topic, that is the binary tree traversals. Here we have the two methods, that is the depth first search and depth first search. But depth first search traverses and breadth first search traverses. Again, the depth first search traverses are divided into the three types, that is the in-order traverses, pre-order traverses and post-order traverses. In the second method is the breadth first search, or this is also known as the level order traverses. First, we have to discuss about the depth first search traverses or depth first traverses. Let us move the next slide. In that slide, have discuss about the depth first search traverses. What is the depth first search traverses means? In this traversing or in this algorithm, how to traversing is start with the initial node of the graph or tree, then goes to the deeper and deeper until we find the goal node or the node which doesn't have any child nodes. The algorithm then backtracks from the dead node towards the most recent node that is yet to be completely unexplored. So in this depth first search algorithm, the data structures of stacks is used. Then already we have discussed about the three methods are there in depth first traversing methods, that are the pre-order, post order or in order. Now we have to discuss one by one in that. Now we have to discuss about the pre-order traversers. What the pre-order traversers means? In this, the pre-order means means in front. Here pre-order means in this traversers the route will be traverser first. Pre means in front. The name itself showing that route will be traversed first. Then you have to traverse the left subtree. Then traverses the right subtree. This is the algorithm for the pre-order traversal. So let us move the next slide. In the slide, how the programming is for these pre-order traversals. This is the recursive. By using the how the recursive by using the recursive function, the programming is like that. Here the root node is having the left subtree, right subtree, which is the root node first, then which is the left subtree, then right subtree. If the left child of main root having the again left and child node, then we have to use the recursive function. Here which is the root node, then left child. If left child doesn't have the any subtree or any nodes, then we have to move the print the left child, then move the right child. If the left child having the left subtree, left node and right node, again go to the main function with checking whether doesn't have any child of left subtree of that or not. In this the recursive manner the programming is written like this. Let us move the next slide. In that we have to discuss by using the binary tree. Here A is the root node, B and C. This is the binary tree. Because A is the root node, it has containing the at most two children of B, C. In this pre-order, we have to traverse the root node first. What is the root node here? A is the root node. Then we have to visit the left subtree. Here left subtree is only the B. B doesn't have the any child. Then move to the right child. What is the right child of A means? Here C. This is the pre-order traverses method. So let us move the next example. In this, we have take the bigger search tree, binary tree. In this, how we evaluate traversing in this tree? We have to check now. Here A is the root node, then B is the subtree. This is the subtree of left subtree of A. This is the right subtree of A. Here then in pre-order root already visited. Then come to the left subtree of A. Here this is also a subtree. Again B is the root here. It having the subtree left subtree of B is this one. Right subtree of B is this one. So then move to here. In this again this is the binary tree. Here D is the root node. G comma H is the pre-order G comma H is the left and right child. Here in pre-order traverses, what have to traverses first? Here root node is the traversing first. So here D is the here A is the left child. B you have to check. Then left child. Here in this left child we have to traverses the D. Here D, what is the G? G is the left node, then H is the right node. So here left subtree of B is completed, then we have to move the right subnode of B. Here again in this E is the root node of I. So we have to first which is the E node, then left node of E. E doesn't have any left node, then move to the right node. By this traverses, the left traversing is completed, then move to the right subtree of A. Here in this right subtree, SCFJ is the right subtree of A. Here C is the root node of F comma G, F comma J. So See, we have to traverse first, then move to the left node of F. F is the root node, and F we have to traverse the F first, then F doesn't have any right child, then move to the F doesn't have the left child, then we have to move the right child J, and C doesn't have any right child, so our traversing is completed. So we have to check no node is no node unvisited, no node is there, so our traversing is completed. This is the evaluation of pre-order traverses in this binary tree. Let us move to another example of expression tree. This is the expression tree. Here in pre-order we have to traverse the first, we have to visit the root node, that is the slash, then have to move the left subtree of slash, that is the this one. Then in this again star have to visit first, then go to the left subtree, this is the left subtree, then have to toss the plus first, then have to move the left one of A have to visit the A doesn't have any subnodes, then here A is completed, then move to the right subnode of plus means B. By this left subtree of slash is completed, then move to the right subtree of star, that is this one. In this minus have to traverse the first, then left node of C doesn't have any node, then move to the right subnode of minus, that is D. By this we have completed a total left tree of root node, that is the slash. Then move to the right node, right subtree of slash. Here this is the right subtree of slash. In this have to traverse the root node, that is the plus, then we have to move the left node of plus means E. So E doesn't have any further nodes. Let's move to the right child of plus means F. So this is the how we traverse in expression tree by using the pre-ordered traversers. So coming to usage of the pre-ordered traversers. What is the uses of pre-ordered traversers means? To create a copy of the tree and also to get the pre-expressions of an expression tree. In last slide only we have saw the how evaluate the prefix expressions of expression tree by using the pre-ordered traversers. These are the uses of pre-ordered traversers. Now let us move the next one. Now we are going to discuss about the in-order traverses. What is the in-order traverses mean? In order means it was in order. That means we have to traverse the left subtree, then visit the root node, then traverse the right subtree. This is the algorithm for in-order traversers. Then in the next slide, have to see the how the programming for this in-order traversers by using a recursive program. Here the in-order traversers 3-pointed PTR doesn't equal to the null. We have to visit the left child, then visit the root node, then visit the right child. If the root node is doesn't have any child, it print the root node. If the PTR to left child is containing the any further childs, then it comes to the again PTR doesn't equal to the null, then come to these these expressions. So this is the programming for in-order traversers. Let us see how the in-order traversers is take place in same binary tree which was already gone through the pre-order traversers. Here ABC is the binary tree, A is the root node, B is the left node of A, C is the right node of A. In-order traversers had to visit the left subtree first, then root node, then left, left node, root node, right, right node of main root. This is the BAC, is the in-order traverses method. So let us move the next example. Here consider the somewhat bigger binary tree than compared to the previous one. Here A is the root node. Here this is the left subtree. This is the right subtree. Then here we have to first have the left subtree of main root node. This is the left subtree of main root node A. Here again this is also a binary tree. Let us move the this subtree here B. B is the root node of left subtree and right subtree. Then come to the left subtree because it is the in-order traverses. In-order traverses had to visit the first left subtree. Here again another binary tree is there. In the D the root node, G the subtree, left node of D. So we have to check our traverses. We have to visit the G the first, then root node, that is the D, that is the H is the right node of D. By this we have completed the left tree of B. Then B have to visit, then right subtree of B is EI. In this E does it have the any left node? So directly have to visit the E, then I. By this we have completed all the nodes which are present in the left subtree, then A, then right subtree. Here we have to move for right subtree. In this right subtree, C the root node, F is the left child. F doesn't have the any further left node. It is having the J the right node. For this, we have to visit the F first, then J is the right node of F, then C, then doesn't have the any nodes in C. By this, we have completed all the nodes of visiting by using the in-order traverses methods. By using the projection, how we evaluate of these three by using the in-order means here just G, H, D, H, B, E, I, A. The quotient F, J, C. In this in-order traverses, we have to evaluate in this expression. By using the expression trees, how we evaluate means here slash. Just come to this example. Here slash is the main root. This is the left subtree. This is the right subtree. This is the in-order traverses. Though we have to first visit the left subtree, then root node, then right node. Here this is the left subtree. This is also binary tree. Then come to this one. This is the root node. This is the left subtree. This is the right subtree. Here again in left subtree we have the binary tree. For this plus is the root node. A is the left child, B is the right child. So we have to evaluate A first, then root node, then B. By this the left subtree of star is completed. Then we have to visit the star. Then have to right subtree of star means this one. In this is also a binary tree. Here see the left child of minus. We have to visit the left child of C minus means C. Then root node. Then right subtree of minus means D. By this we have completed the total left subtree of slash, then slash we have to visit, then right subtree of tree. Here right subtree of slash is also a binary tree. This is the binary tree. Here, so in order traverses means we have to visit the left node first, E the left node, then root node, then right node of plus means F. By this we have completed all the nodes in this expression. This is the in order of expression tree. So what are the uses of in order traverses of binary search or binary tree? Means in case of binary search trees, in order traverses gives the nodes in non-decreasing order. That means it gives the increasing order. If we have if we want to decreasing order, just have to reverse the or to go the order by using the in order expression. So next we have to discuss about the order post order traverses method in the next video. Thank you.